You may be wondering what are the differences between ROS1 and ROS2 and what does it change for you as a ROS developer? Well, ROS1 versus ROS2, let's begin. And first of all, to be clear and not bring any confusion, I will use the term ROS when talking about robot operating system in general, which is the ecosystem, the philosophy behind ROS, the community, etc. And I will use ROS1 and ROS2 when talking about the specific ROS versions. So the first question to ask is maybe that one. Why ROS2? Why not just keep ROS1? Okay, here is, well, a quick explanation of that. So ROS1, initially created in 2007 by Willow Garage, has become huge among the open source robotics community. The team behind ROS1 has learned, with all those years of experience, what important features are missing and what could be improved. Unfortunately, adding all those modifications to ROS1 would have required many breaking changes and make ROS1 quite unstable for a while. Okay, so ROS2 was developed from scratch and is a completely new ROS. Okay, as for now, ROS is not very popular in the industry, and more specifically ROS1, because it lacks some of the most important requirements, such as real-time, safety, certification, and security. Just a few examples. One of the goals for ROS2 is to make it compatible with industrial applications. Okay, so we are not there yet, but this is one of the goals of ROS2. Let's now talk for a second about ROS1 and ROS2 distributions. So here is the situation with ROS1. You can see on the left, I have ROS1 distributions here. So ROS1 Noetic, which was released in 2020, is the last ROS1 version. This final ROS1 version, so the main goal for this version is to provide Python 3 support for developers and organizations who still need to continue to work with ROS1 for a while. And the end of life for Noetic, actually if I go here, the end of life is May 2025. After that, there is no more ROS1. So if you have a big code base in ROS1 today, it's totally okay, but don't wait until the end of 2024 to start making changes. So you still have time, but of course it's better not to wait the last minute. And for ROS2, you can see that from the version Foxy Fitzroy here, which is a long-term support, which was also released in 2020, we will have a new version every year, so 2021, 2022, etc., etc. So it's very quite similar to what was done for ROS1. Okay, you have a new version every year, and then a new LTS version every 2 years. So 2020, 2022, and then 2024, 2026, etc. You can already start working with ROS2 right now, okay, because it's already pretty stable, at least for the core functionalities, okay, because some third-party plugins are still missing or not stable at all. One thing to know also is that even if ROS2 has been completely rebuilt from scratch, well, most of the ROS concepts are gonna be the same between ROS1 and ROS2. So if you were already familiar with ROS1, with one of those distributions here, it's gonna be much easier for you to learn ROS2 with one of those distributions. And now that you understand a bit more why, okay, we have ROS2 and what are the different distributions you can use for ROS1 and ROS2, let's explore the differences between ROS1 and ROS2. I have separated them into 3 main parts, okay, in order to have some sort of a structure. First, we're going to see what are the differences when you write code. Okay, so when you write code in ROS1 versus when you write code in ROS2. Then we're gonna focus on the communications. Okay, so what are the differences in the different concept and communication in ROS1 and ROS2? And finally, we're gonna focus on the environment. Okay, packages, the workspace, environment, everything, with the differences, of course, between ROS1 and ROS2. And so let's start with the first point. What is going to change for you as a ROS developer when you write code? So let's talk about the ROS API, or basically what you're gonna use directly in your code. So the Python library, the C++ library, etc., etc. In ROS1 for C++, you use ROS CPP, and for Python you use ROS API. Both libraries are completely independent and built from scratch on top of TCP and UDP. It means that the API is not necessarily the same between ROS CPP and ROS API, and some features are only going to be developed for the one and not for the other one. So it has happened to me a lot of time that there is a ROS CPP functionality I want to use in Python and it's just not there. On the opposite, ROS2 has more layers. Okay, so there is only one base library which is named RCL, okay, and implemented in C language. This is the foundation which contains all of the ROS2 core features. So you will not use this RCL library directly in your programs with C code. You can do that if you want, but you can use another client library built on top of RCL. For example, rclpy for Python, rclcpp for C++. Okay, so instead of using ROS API, you're gonna use rclpy, and instead of using ROS CPP, you're gonna use rclcpp. As simple as that. But then what's great about this change of architecture? Well, basically with this, any new functionality only needs to be implemented with the RCL library. And then the client libraries on top of RCL just need to provide the binding. Okay, so the functionalities are not implemented in rclpy or rclcpp, but in RCL with a binding with the upper library. And well, for you as a developer, what does it mean? Well, first, the API between rclcpp and rclpy will be much more similar, okay, between Python and C++ than the API between ROS API and ROS CPP in ROS1. Second, it will be easier to create and use other language client libraries, for example, RCL Node.js, RCL Java, etc., etc. You don't need to reinvent the wheel here, you just need to make a C binding with the RCL library. Okay, any library you create, RCL, whatever your language you want, you're just gonna make a binding between this library and RCL. So it's super easy to do. I mean, super easy, relatively. And well, so all clients in all languages can have a similar API, which is great. And the third point is that when a new core functionality is released, it's gonna be available sooner in different languages. Okay, so you don't have to wait too much. Okay, because before, let's say you have a new functionality in ROS CPP in ROS1, well, you have to wait that someone, or you have to do that yourself. So you have to wait that the functionality is going to be ported to ROS API from scratch. In ROS2, well, it's just another binding to add, so it's much quicker. Let's now talk about Python and C++ versions, okay, for ROS1 and ROS2, and for that, let's come back to the page here on ROS1 distributions on the left and ROS2 distributions on the right. So as you may know, I mean, I probably know that Python 2 is not supported anymore. Well, in fact, to provide a smoother transition, it is still going to be supported for Ubuntu 18, okay, and for ROS1 melodic here, okay, until the end of life, which is 2023. So that's quite soon, actually. ROS1 Noetic here targets Python 3 directly from scratch, okay, as well as any ROS2 version. So if you want to use Python 3, you only have ROS Noetic, so you only have this option, and then with ROS2, any version that you see here in green is gonna target Python 3. Now for C++, there is some great progress. Okay, ROS1 was targeting C++ 98, and you could use C++ 11 and 14 in later ROS1 versions, provided that it didn't break any dependency. In ROS2, you can now use C++ 11 and 14 by default. C++ 17 is also on the roadmap, and that's great because new versions of C++ will introduce many useful functionalities. okay, making the development much easier, quicker, and safer. Also, it makes C++ more fun, and maybe this will help democratize this powerful and great language. Well, seems I'm a bit biased here by C++. Alright, now what is the difference when you're gonna write your nodes? Okay, so you already see here, like for example here, so I have a ROS1 code here and a ROS2 code here. You can see we use ROS API and we use rclpy. Okay, so that's already one difference. But now, well, in ROS1 there is no specific structure telling you how you should write your node functionalities. Okay, you can decide to add callback functions like I did here. So you can add them anywhere. You could use object-oriented programming to create classes if you want to, but well, everyone's implementation could be unique. And if you look at GitHub pages for ROS1 project, well, you will see that many people have many different ways to write nodes. So there is no clear convention on how to write a node, I would say. In ROS2, things are different. There is no a convention about how to write your nodes. You have to create a class which inherits the node object, okay? So you can do that in Python, but it's also the same thing in C++. And in this class of the node, you will have all the node functionalities. So all the ROS2 functionalities for the node are gonna be implemented in that specific class. This is great. Why is that? Because it will save everyone a lot of time. You already have a good modular structure for writing your node. It will make your programs cleaner, and cooperation between developers on different projects will be easier. Okay? And using object-oriented programming for your nodes in ROS2 also allows you to convert them to components, which is a new feature in ROS2. Let's see that right now. So let's talk about ROS2 components, which is something that doesn't exist in ROS1, it's new in ROS2, okay? In ROS1, a node is tied to an executable. Okay, so you have one executable with one node, one executable with one node, etc., etc. And so you need to run all those executables, and then all those executables, all those processes are gonna talk between each other, okay? A new functionality named nodelet was added to ROS1 to be able to write multiple nodes in the same executable using what we call intra-process communication. Okay, and that was the solution so that you could have potentially multiple nodes inside one executable. And this solution is great when you have limited hardware resources, for example, or if you need to send a lot of messages between nodes. Okay, that's gonna be easier to communicate from inside, okay, from within an executable than from one executable to another executable. In ROS2, nodelets are not called nodelets anymore. Okay, the functionality has been directly included in the ROS2 core functionalities and is now called, well, components. Okay, so if you already know what is a nodelet, you kind of know what is a component. And well, as you can see in ROS2, you can handle many nodes from the same executable using the components. A component is simply a slightly modified node class, okay? And as you could see before, we were using object-oriented programming. So from that class with OOP, you're gonna create a slightly modified class, which is going to be a component. Okay, so very practical and very useful. And then, well, you can start your components from a launch file, from the terminal, or from an executable. Okay, you can activate intra-process communication to remove any ROS2 communication overhead. Okay, so remember that building components is a very good practice to create efficient ROS2 applications. If you are just learning ROS2, well, don't worry about components for now. This is more of an intermediate level that you're gonna see after you're familiar with the topics, the services, etc. And let's now talk about ROS2 lifecycled nodes. So ROS2 introduces the concept of lifecycled nodes. A lifecycle node has different states. Okay, it's gonna be first unconfigured, and then it can go to inactive. It can then go to active, and you also have a final state here, finalized. This is very useful when you need a setup phase before you actually run your node's main functionality. When you start such a node, it is initially unconfigured here. And through the provided interface, which are ROS2 services, you can ask for a transition to another state. When you do that, a predefined callback will be triggered inside the node. Okay, for example, here, you can see on configure, you will have a callback. On cleanup, you will have a callback. Everything in yellow here, you will have a callback that you can run in your code. So let's say as an example that you have a node for a sensor. You first need to make sure that the sensor is detected, so it's correctly plugged to your computer or your Raspberry Pi or whatever. And then you want to make sure that the communication has been successfully started. After that, and only after that, you can start your reading loop, okay, to publish the data. So with a lifecycled node, you can clearly separate this. First, you allocate the memory for the publishers, the subscribers, and other objects that you need to instantiate. And then you initiate the communication with the sensor. And finally, you run the reading loop and you publish the data. And you can do that in different states, okay, of the lifecycle node. And now let's talk about launch files, okay? So launch files in ROS allow you to start all your nodes from just one file. You can start a standard node, a component, a lifecycle node, everything, okay? You can add arguments, parameters, and many other options. So in ROS1, you've been used to write launch files that look like this, okay, with XML. In ROS2, you will now use Python to write your launch files, okay? There is an API allowing you to start nodes and retrieve configuration files, add parameters, etc. It will allow you to customize your launch files much more than before with XML, okay? However, is writing a launch file in Python really new? Well, in fact, no. In ROS1, there is also a Python API. What is the problem with this Python API? No one is aware of it, and there is almost zero documentation about it, so no one uses it. That's simple as that. And well, it became quite the norm to use XML to write launch files, okay? This is great, but certainly not as modular as with the Python API. Okay. In ROS2, you also have an XML API kind of, so you can also create ROS2 launch files in XML if you want to. But I think I prefer using Python because it brings more modularity, it's more documented also, and it has become kind of the ROS2 convention for launch files. Alright, so with all those points, we are now done with some of the most important changes and additions in ROS2 regarding how you are going to write your code. And if you want to learn how to write code for ROS1 or ROS2 in a practical way, I have created some courses that will help you to progress much faster. ROS1 for beginner here, ROS2 for beginners, and also ROS1 for ROS2 developers. So you can click on the links in the descriptions, okay, to get access to the courses. All of the courses are step by step, and in the videos I just go to the points, so you don't waste your time and you actually learn how to apply the ROS concept to develop your own applications and your own projects. Alright, and now let's continue with the video. Now that we have seen some of the main changes when you code, let's look at the differences between ROS1 and ROS2 when it comes to ROS communications. And let's start with this ROS master. So one thing you've learned with ROS1 is to always start a ROS master before you run a node. Okay, the ROS master will act as a DNS server for your nodes, so they can retrieve each other information and communicate. In ROS2, well, guess what? There is no more ROS master. This is no more a centralized system. Each node has the capacity to discover other nodes. You can simply start a node without having to worry if you have a master running or not. And this change is great because it allows you to create a fully distributed system. Each node is independent and not tied to a global ROS master. So for example, when creating a multi-machine ROS2 application, you won't have to define one machine as the master. Each machine will actually be independent, kind of its own master, and be able to start on its own, connect and disconnect with each other with less setup actually than in ROS1. ROS2 parameters. So in ROS1, parameters are handled by the parameter server, which is itself inside what? Inside the ROS master. And then each node is gonna grab the parameters from this parameter server. So of course, everything is tied to the ROS master. In ROS2, you don't have any more ROS master, so you can't have a global parameter server like in ROS1. So the concept of parameters has been completely changed. There is no global parameter anymore. Each parameter will be specific to a node. Okay, so a node declares and manages its own parameters, and those parameters are destroyed when the node is killed. So it's kind of like if each node has its own parameter server. When you start a node, a few ROS2 services are created for that specific node. Those services will allow you to interact with the parameters of the node from the terminal and also from other nodes. In addition, you can easily modify a node's parameter after they have been created using a parameter callback. So if you were familiar with the dynamic reconfigure tool in ROS1, well, good news, now this tool is actually part of the core functionalities. No more extra configuration that can be quite difficult to do. Okay, all you need is to bind a parameter callback using the API. So for example, rclpy and rclcppp. So you bind this parameter in your node so that you can get this callback called to modify the parameters on the fly. And so as you can see with this example here on the screen, we have a camera driver node with 3 parameters, and at runtime, those parameters are going to be set. And you can see we can have different parameters for different nodes, and each node will have its own set of parameters. And when you kill the camera driver 1, for example, well, the parameters inside the camera driver 1 are gone, but the other parameters, for example in camera driver 2, are still alive because they are independent and only linked to this specific node at runtime. Let's now look at services. So in ROS1, services are synchronous. When your client asks a request to the server, it is stuck until the server responds or the server fails. In ROS2, the services are asynchronous. When you call a service, you can add a callback function, which will be triggered when the server responds. In the meantime, your main thread is not stuck. And of course, if you want, you can also have the option to use the services in a synchronous way, okay? Because it's not always better to do asynchronous or synchronous, okay? Sometimes one is better than the other one. It completely depends on what you want to do in your application. Okay, let's switch to ROS actions. So in ROS1, actions were never in the core functionalities. It was an addition made after a few years to solve the problem that, well, services were not asynchronous and did not have a feedback mechanism or a cancellation mechanism. Okay, so ROS actions in ROS1 are entirely built on top of ROS1 topic, okay, because it was added later on top of topics. In ROS2, actions are now a part of the ROS2 core functionalities. The API for C++ and Python is quite similar as for ROS1, so no problem with the code here. You will be able to easily use a ROS2 action if you correctly understood what was a ROS1 action. And underneath the surface, actions still use topics for feedback and goal status, but also asynchronous ROS2 services for setting a goal, canceling a goal, and requesting a result, okay? And now actions also have their own command line tool. Okay, you have the ROS2 action command line tool, okay? As you would do with a service, you can now send an action goal to a server directly from the terminal. And to continue with, well, we have seen the different communications, but now with the communication, so you have the type of communication, for example, topic, service, and action, but you also have what is sent, okay? So the messages. And let's talk about the messages and actually the definition of those messages, okay? So for messages, services, and actions. So the way to create definitions for messages, services, and actions is quite similar in ROS1 and in ROS2. You still put them into a MSG, an SRV, and an action folder, okay? But after you compile them, a namespace is added in ROS2, okay? So in ROS1, you don't have any namespace. All the messages and services and actions are gonna be in the same place. But in ROS2, you have those new namespaces. Let's see that with an example. So let's say you have a package named My Robot Messages. And inside this package, you create a message here, temperature, and a service activate button. Now you're gonna compile, okay, with ROS1 and or ROS2. And after the compilation, if you want to use those messages and services from other nodes, here is what you have to do. So you can see in ROS1, you just put the, so the namespace is actually the name of the package and then directly the interface. In ROS2, you would have the name of the package slash the type. So if this is a message, a service, or an action, and then slash the name of the interface. Okay, so that's an additional thing to do when you use definitions in your code. And this is also a great thing because it reduces the confusions, okay? It makes the separation clearer between all three types of communications. And to end this second part, let's talk about quality of service. So ROS2 introduces QoS, or quality of service. With that feature, you can choose how your nodes handle communication. Do you want to make sure you receive all the messages? Or is it okay to lose a few messages as long as the data is frequently updated? Do you want to keep a queue of messages in case a node doesn't have the time to process them all? Or do you want to drop any new message if a callback for a previous message is still running? Well, if you have to ask such questions for your application, well, you will need to tune the QoS for your node. And by default, so QoS was not customizable really in ROS1, it's not customizable in ROS2, but by default, the QoS for ROS2 communication, okay, for topics, services, etc., has been chosen so you can expect the exact same behavior as for ROS1. So if you don't configure anything, you will get the same configuration and you don't need to worry about this too much. So what is the default configuration? Well, basically any node that is subscribing to a topic will not receive the previous messages, okay? When you subscribe, you only receive the messages that are published forward in the time, okay? After subscribing. Also, like in the TCP protocol, the messages are guaranteed to be delivered. And you can also set a queue size for delivered messages waiting to be processed in a callback. So in your application, if you have to deal with a lossy wireless network, okay, that is not quite stable, if you have a large message bandwidth, QoS is maybe a setting worth looking at. But if you are just getting started with ROS or have a very simple application, well, usually don't worry about QoS for now. Just have to know it's here and then you can work on it later when you really need it, okay? There are more important things to learn first because ROS is quite big. And that's pretty much it for the tour of differences regarding ROS communications. And let's now have a look at the differences between ROS1 and ROS2 when it comes to the environment around your code and the ROS communication. So this is a bit broader, okay? We're gonna see everything that's around the ecosystem of ROS2. So first, how to build your nodes? Well, the build system in ROS1 is catkin. Okay, so you can use catkin make, for example, like this, or you can use catkin build, in order to build and install your packages. In ROS2, well, there is no more catkin. Ament, so ament written like that, is the new building system. And on top of that, you also get the callcon command line tool. Okay, and to compile a package, you're gonna use callcon build. Okay, so instead of catkin make or catkin build, you are going to use callcon build. So there is much more to say about ament and callcon, but with just this information, you will be able to build your first nodes without any problem. Let's now have a look at the command line tools. Okay, so here in this terminal, I have sourced ROS1. In this terminal, I have sourced ROS2. And most of the command line tools are very similar between ROS1 and ROS2. The name of the tools and some options are maybe different, but otherwise there is no big difference when you use them. For example, to list all topics in ROS1, you would do ROS topic and then list. All right. In ROS2, you would do ROS2 topic and then list. That is very similar. Okay. So in ROS1, you would have a different command for each feature. For example, ROS topic, ROS service, ROS bag, etc. In ROS2, you just have the ROS2 command line, and then everything is an option. Okay, so ROS2 topic, ROS2 service, ROS2 bag, etc. Let's do tab here. So let's do auto completion to see all the actions you can do. Okay, so ROS2 pkg for ROS2 package, ROS2 node, ROS2 run, ROS2 launch, etc. So this is very similar to what you had in ROS1, just the syntax is a bit different. You just have to start with ROS2 and then name of the tool, and after that name of the options. Okay. Let's now look at packages, so ROS1 packages and ROS2 packages. With ROS1, well, you just create a package, that's it. And then you add any C++, any Python file you want, anything you want. A package is just a package. With ROS2, now you're gonna make the difference between a C++ and a Python package. Okay. When you create the package from the command line with this command here, ROS2 package create, name of the package, you will have to provide a build type. Okay, either ament CMake for C++ or ament Python for Python. Okay, and depending on that argument, the package architecture will not be the same. Okay, so let's look at this here. So here I have a C++ package and a Python package. In the C++ package, well, things are quite similar with ROS1. Okay, you will have a cmakelist.txt, you will have a package.xml. All right, and just in the cmakelist.txt, you will need to adapt the cmake instructions so that you use ament cmake. Okay, you use ament basically and not catkin. All right, so then you have the source folder, the include folder. Well, that is pretty common in C++. So source folder, include, and then cmakelist.txt. So that's very, I would say, simple and classic for a C++ package. Now for a Python package, things have changed a bit. For a Python package, things are going to be different. Okay, so first of all, you still have the package.xml. Okay, for any ROS2 package, you will have a package.xml, whether it's for C++, Python configuration, etc. Okay, so that doesn't change. But then you have some new files. For example, you have setup.py. Okay, and this kind of replaces the cmakelist.txt. So cmakelist.txt for C++, but then you have setup.py for Python. Okay, and one thing that is different is that with Python now you are going to also compile your nodes. So before you just, in ROS1, you just create a Python executable, okay, and you just run it like that. With ROS2, if you want to start the nodes from ROS2 command line tools, okay, or from a launch file, you will have to actually not compile them, but install them using first callcon build, and you will put the specification for colcon build here in the setup.py. So you can still start any node that you're going to create here directly from the terminal, just execute them, but you can also start them using ROS2 functionalities after you have installed them and providing the information in the setup.py and using colcon build. Okay, you can see for Python packages we have the name of the package and then a folder which has the exact same name, which contains your nodes, for example, and then you have also a setup.cfg, which is a new thing for ROS2 Python packages. And you can also, this is another option, so you can also, if you want to create a ROS2 package for both Python and C++, but this requires a little bit more setup. So overall, setting packages up in ROS2 is a little bit more complex than in ROS1, but it's also more complete and better organized. Let's now see how you can source your workspace, and let's talk about overlays. So sourcing your ROS environment is not so different between ROS1 and ROS2. You first source your global ROS installation and then your workspace, and you can use your custom code. Okay, so in ROS1, source installation, source workspace, that's it. ROS2 brings the concept of overlays. You can have multiple workspaces on top of each other. So first, like in ROS1, you would source your global ROS installation. Then your first workspace, which is the first overlay, your second workspace, etc., etc. So here, if a package has the same name in a lower level overlay and a higher level overlay, then only the higher level one will be used. So when you develop your application and you already have a certain number of packages, you can create an overlay for just one package. This will allow you to quickly iterate on the package while keeping your code base unchanged for other projects. Okay, this is very useful. This can be a very useful functionality for development. With this technique, you can also override a package which is already installed from binaries. So let's say you want to use the global ROS2 installation and with your packages, but you just want to replace one specific package in the global ROS2 installation. Then instead of, just building everything from source and modifying that package, you can just build an overlay for that specific package, and that's gonna work, and you don't have to do complicated stuff. All right, so this is very practical. You can keep the package installed while having your own version of that package for a specific application. And let's look at which operating systems or which platforms are supported for ROS1 and ROS2. So as you may know, ROS1's main target is Ubuntu. And great news for ROS2, because thanks to its new architecture, you can install it and use it on Ubuntu, Windows and Mac OS. You have other OSs, of course, but those are the three main ones. Okay, so those should work quite good. Okay, and this is good because this is going to make ROS2 more accessible and more embeddable in many applications. For example, you could have a mobile robot with a Raspberry Pi and Ubuntu, and another computer on the same network using Windows for a specific 3D simulation tool and a driver node for a camera scanning the scene. Okay, and all of that can run smoothly together, even with different operating systems and different machines. All right, we have now seen most of the main differences between ROS1 and ROS2. Now, the list presented here is certainly not exhaustive, okay? It's quite long, but not exhaustive. And some information is also subject to change in the time because ROS2 is still evolving a lot. So what I said now is maybe going to change in 2 years or 3 years. Who knows, okay? Now the $1 million question, when to switch from ROS1 to ROS2. And it's not as simple as that. And many people will tell you different answers, okay? So I'm going to give you my version of things, okay, that you can use as a guide to maybe help you take a decision. All right. So ROS1 is still strong with many stable plugins, more documentation, and third-party plugins. Okay. Eventually it will end, but you still have a few years before that. Okay. So ROS1 is not dead yet. All right. So that is very first important information. So I'm gonna do 3 cases here. First of all, if you are new to ROS, so you're completely new to ROS1 and ROS2, well, first of all, congratulations for watching all the video, because I don't know if you could really understand anything I said. And no, so if you're new to ROS, well, you should probably learn ROS2 fundamentals first. But then it can also be interesting also to get a taste of ROS1 too. Why is that? Because you may understand some things in ROS2 better if you also see how it is done in ROS1, okay? And also some tools and packages you want to use may not be yet ported to ROS2, so you will have no choice but to use the ROS1 version of the package. And in this case, you can use the ROS1 bridge package, which I'm going to introduce in just a minute. The second case is if you already know ROS, so you already know ROS1, of course, and you want to start a brand new project. Then going the ROS2 way is probably what you should do, so it means less transition work in the future, okay? The core concepts between ROS1 and ROS2 are similar, so the more experienced you are with ROS1, the less time it's gonna take for you to learn ROS2, okay? And if everything is in ROS2, then you don't need to migrate the code in a few years when ROS1 is completely over, okay? And again, you can use the ROS1 bridge package if you want to communicate between ROS1 functionalities and ROS2 functionalities in order to use missing tools and plugins. All right, I'm just going to introduce that in a minute. And the third point here is if you already have a code base in ROS1 for one or more of your robots, or for a complete organization with dozens of developers, well, switching to ROS2 may represent a lot of work. Okay, this is not an easy answer here to give. So the bigger the code base and the influence of ROS on your project, the longer it will take and the more complex it will be. Of course, you may choose to continue working with ROS1 for legacy projects and start working with ROS2 for new projects. Or you could also start porting all your code to ROS2 now, knowing that there is a lot of work involved, and also depends on how well your code is actually written. Okay, so it depends not only on ROS, but on what have you done before. And first, before you decide to make the complete switch between ROS1, so from ROS1 to ROS2, make sure that most of the ROS features that you need have been ported to ROS2, okay? You don't want to migrate a code and, well, nothing is here and you need to create everything from scratch, okay? And again here, ROS1 bridge may be helpful for you for the transition. And now that I've talked so much about this, what is ROS1 bridge? Well, if you need to work with an existing ROS1 code base but want to develop new features with ROS2, you are not necessarily stuck. You can use the ROS2 package named ROS1 bridge, which will make, as its name suggests, a bridge between ROS1 and ROS2 communications, okay? Even if the concepts are the same between ROS1 and ROS2, the communication underneath is not directly compatible, okay? You can't just have a topic, like for example, a camera topic on ROS1 as a publisher, and then subscribe to this camera topic from ROS2. It's not gonna directly work, okay? You need that bridge, all right? So you need this package, which is going to provide the bridge between all possible interfaces. So when doing a migration to ROS2, you can start porting a few packages in ROS2 and make those packages communicate with the rest of your ROS1 application. Then you port more and more of your packages until there is nothing left written in ROS1. During all the migration time, your application can still work as expected, and then boom, you just have everything in ROS2. And now that you've seen the difference between ROS1 and ROS2, well, let's take some action and let's actually learn ROS, right? So I have created some courses about ROS1 and also ROS2 that will help you get started in just a few hours. Those courses are really practical, and I just go to the point so you can understand all the concepts and know how to apply them in your code for your own applications. So whether you want to learn ROS1 from scratch, or ROS2 from scratch, or even learn ROS2 as a ROS1 developer, then, well, I have a course for you. Check out the links in the description. Thank you for watching, and well, maybe see you in one of those courses.